Hey, let's talk about function data types and callbacks in C++. So I'm in Visual Studio just with an empty project, and we had talked about how we can store functions, references to functions in a variable using the standard function data type. But we've been able to do something like this even in the C language, the predecessor to C++. But if you think about or the C language, they didn't have this idea of reference types. They didn't have classes even, and really when you wanted to reference something, say you want to pass by reference, or you want to make a variable that refers to another one, it has to be done with pointers. And so even with functions, if you wanted to refer to a function and not just call a function, you would have to be referring to it through a pointer. So in C++, there are function pointers, and the syntax for it is really kind of a mess, and this is why we will never use them. So let me just write a function. Let's say print number. Okay, it's a nice little function. Let's do something. This is not going to be C. Because I'm using C++ stuff here. Let me give it a parameter. Okay, but if you want to see C code, you can just bug me anytime. So we'll be printing out this number. Great. Now if I wanted to write a function pointer that refers to this kind of a function, the function pointer is essentially giving a different name, sort of like an alias, to this function, referring to it by a different name. And the important parts that affect the data type of this function are the return type and the argument list. So we have a void return type, and we have just a simple argument list that just has an integer in it. So the type that we're working with is that void, and then the stuff that we're referring to, I'm going to be calling my function pointer, and then in parentheses we put the it takes an integer, right? So this is a variable declaration. It does not look like it at all. It is this looks like a disgusting mess to me. But what it's saying is that the stuff that's pointed at by this variable is a function that returns void and takes an integer. It's very hard to read. I really don't like it. And we can assign a value into this variable. So just like we would say int my num equals 5, well, we can say this variable, this new variable, is let's say print number. And this is a pointer, so you can use an ampersand, the address of operator, to get the address of this function. But C, because it's trying to be nice and present us a nice clean language, you can leave that off. It's not much. Alright, then once you assign it that way, you can call it. So my function pointer, and give it my num. Alright, and it'll call print number through this pointer. Dereferences this pointer, invokes the function, and calls it that way with that value. Alright, so this is gross. Much better is what we did in the last video. If you include the functional header, you can do this same thing, but with the standard function type. And you can assign the same kinds of things into this type. So this is much cleaner, easier to read. It's clear what it is. It's a function, and what type it has, returns void, takes an integer. I like this syntax a lot better. So with C, you would use function pointers, and you could do the same things essentially, but this is a bit more flexible and readable. One of the nice things you can do with either of these is to implement what are called callbacks. So a callback is simply a function that gets called, and you tell it which function to call. So to be able to do that, you need to be able to reference one function or another and change that reference. So in C++, you could use either a function pointer or a nicer function object like this. And let's create a class that performs a callback. So let's say I have, this great named class, my class, and it has maybe a function in it that's an update function, and then maybe it has one of these reference things. So let's say function, let's not give it any data, that's fine, it's just a test. And then I'll call this thing on 10th frame. So this will be a callback that is going to be called on the 10th frame. This could be like in Unity, there's like on enable and on disable, or on collision begin or enter, or whatever it is. So this is just a naming convention for a sort of callback, sort of like an event that happens. So this particular event is when the 10th frame happens or starts. And so I need some idea of which frame it is. So let me make frame number. Alright, let's start at frame 1. And then every time we update, we can do frame number plus plus. Alright. And now we know we would like to call this on 10th frame function if the frame number is 10. Okay. On 10th frame. Alright, so I'm using it just like it's a normal function, but this could be reassigned to anything. So now in my other code, let me create a function to be called by this. Print something. Okay, real great. And then we'll create my class object. And let's do this. Let's do a loop. Let me just do it forever. Alright, while true, object dot update. Okay, so this will run forever. It'll continuously call this update function, and I would like it to not do that without me telling it to. So I'm going to also cin.get, so it'll wait for me to press something. I'll just press enter, and I also need to set my callback. So on 10th frame is print something. Alright, so I should expect this is going to run. It will call this part, so it's going to call this print number function. I should also demonstrate, I guess, my other function. There we go. So it'll do that twice, and then it's going to start updating, and I have to press enter each time, and after 10 of these it will show me another message. Let's try it out. Alright, there's my two numbers. 7, 8, 9. Okay. 1 plus 9, that's 10. That works. This is something being printed. Okay, and then I could do other fancy stuff like maybe it's maybe it repeats every 10 frames, every 10th frame. Okay, that's cool. So this is the beginning of a callback system, and you can imagine more complex interactions here, where you might be waiting for two objects to collide, and then a callback happens. Maybe maybe a character dies in your game, and you have a callback that's on character dies, or anything like that, on level loaded or on level ended. You can set up all sorts of interactions in your code that kind of respond to an event occurring, and you can get into this concept of event-driven programming, where your code just kind of sets everything up for which functions are going to be called when some interaction happens, and then you let it run and watch all those things happen. It's a pretty interesting way to do it. So, wanted to show you the syntax for function pointers, and then tell you never to use those, and show you some use of this standard function data type in C++. I'll see you in the next video.